So what can we do with the survey data? The initial ballast problem I mentioned requires a measurement of ballast volume. The following is a time series cross-section of a train traversing through a LiDAR dataset. By computing the ballast volume, we can identify deficiencies and surplus ballast on a meter-to-meter basis. As the vehicle traverses the track, we log the distance and the ballast volume. This report now catalogs and annotates any area where there is a deficient ballast volume or a surplus ballast volume, and this is useful for refilling the ballast in an optimal way. Now that we have seen how a report can help save money on ballast, let's see how we can actually make this report. The current industry standard is to either use GIS consultants or software tools that utilize algorithms. We will briefly go over each approach and inform you about the pros and cons of both. Secondly, we'll introduce you to the civil maps approach as well. Let's start with humans. We are inherently wired for pattern recognition. Our cognitive abilities allow us to think abstractly, and given minimal instructions, humans can annotate point cloud data using desktop software. So one of the approaches under consideration for a project should include humans. Machines, however, are inherently fast, but they are very rigid. Their cognitive capabilities are derived from the programming that drives their components. In this regard, they are only as good as their hardware and software while trying to process point cloud data. However, they can process large amount of data very rapidly. Now, I know you must be curious about this graph I have up on the screen. The purpose of this graph is to walk through a use case to determine when it is correct to use humans and when it is correct to use machines. We will cover the time complexity of processing data utilizing humans versus machine vision algorithms. So we'll revisit this graph in a second. As I mentioned before, humans are abstract thinkers. Their strengths when it comes to processing survey data exceeds that of machines when critical thinking and complex 3D modeling is required. However, if the survey data mainly consists of long, repetitive linear assets, which require little critical thinking to annotate, it makes more sense for a machine to do that work. In the survey and mapping industry, it makes more sense to use human GIS annotation whilst trying to build unique 3D models that would be difficult to train algorithms on. This is particularly useful when trying to create one-off BIM models for a unique project that does not have many linear assets. In this video, we can clearly see that the survey data contains mainly repetitive linear assets. In contrast to the complex dataset in the previous video, this particular dataset has predictable linear assets. It makes a lot of sense to write algorithms that can extrapolate and annotate the features of interest using machine vision algorithms instead of point-and-click methods. In this case study, we present some work we have done for a previous client. We received a LiDAR dataset that spans over 1,000 miles, and it covered a Class 1 railroad's track infrastructure. The Class 1 railroad requested a ballast volume report that annotates deficiencies and surplus ballast every 0.5 meters. The frequency of the report is over the 1,000 mile stretch and is done every 12 weeks. This area is prone to floods and other harsh environmental conditions, including earthquakes. Therefore, this detrimentally affects the stability of the ballast underneath the tracks. The high frequency and the accuracy requirements put a strain on any infrastructure. So what kind of approach would you take? Would you use GIS consulting?